Hello, everyone, and thank you for joining today's webinar, Circular and Architectural Design, Harvesting End-of-Life Opportunities. As you get settled, please feel free to say hello and where you're joining from in the chat. To qualify for continuing education credit, AIA California provides the learning objectives for every webinar and includes them in the PDF presentation that can be made available online. We will provide links in the chat box where you can find upcoming and on-demand climate action and ZNCD webinars from AIA California. A few quick housekeeping reminders. Today's session is being recorded and additional resources will be made available on our website. Today's session qualifies for one AIA HSW learning unit. For those who stay on and watch live, AIA California staff will report these units for you. General certificates of completion can be provided upon request via email. Please use the Q&A function to ask any questions for today's presenter. You can also like a question to move it to the top of the queue. Cultivate a positive learning environment. Please be constructive in your comments and questions to help foster a positive learning experience for everyone. Finally, AIA California is happy to share that our climate action programming is now brought to you by Arup. Sustainable development is everything. I'd now like to introduce our moderator for today. Ismar Enriquez, AIA, has been practicing for almost 2 decades and is currently a design lead and project manager at Practice. As a sustainability leader in California, Ismar addresses issues related to carbon neutrality, resiliency, climate justice, housing and equity, and is involved in government policy change and advocacy efforts across the state. Ismar, thank you so much for being here today. I will now hand it over to you.
Thank you, Sarah. Really appreciate that intro, and thank you everyone for joining us today. Today's webinar, Circular and Architectural Design, Harvesting the End-of-Life Opportunities. Today's webinar will explore the intersection of circular economy principles and architecture, focusing on practical strategies for sustainable design and material reuse, and will show how to integrate circularity into your architectural projects, emphasizing the creation of nature-inclusive buildings with minimal ecological footprints. I'd like to introduce our speaker for today who can help address these questions, Lorianne Isibasi. Lorianne holds a PhD in environmental technology and design and in design for sustainability from the Technical University of Delft in the Netherlands. She focuses on circular economy, life cycle thinking, socioeconomic and technological analysis, and waste prevention, system dynamics, urban metabolism, industrial ecology, and retrospective bottom-up stock analysis. She currently collaborates with SuperU Studios in Rotterdam. Previously, she worked as an architect designer in the Netherlands, Brazil, Japan, France, and Switzerland. She has also completed her master's degree in urban design in Kagoshima University, Japan, where she researched flexible urban infrastructure and building adaptability. Segoi desu. Lorianne, thank you so much for being with us today. Now I'll hand it off to you.
Thank you, Sarah and Smar, for inviting me here today. My name is Lorianne, and the introduction was very clear again. And I am the director of SuperU's US right now. I'm happy to show you some of our work and the approach we have been developing for the past 25 years plus. I think if it's okay, I'll start showing my screen. Let me see if it works. Yeah. Is that working?
We don't see it quite yet.
No, okay.
Starting now.
Perfect.
Yeah.
Great.
Yes, all right. So SuperU's is a company founded by 2 architects from the Netherlands. They also graduated from TU Delft. And as soon as they graduated, they started to question about the role of the architects regarding the production of waste materials. And that was a while ago, before circular economy was a big topic. And actually, it was even before Cradle to Cradle. So despite all these different titles we see today, and they keep changing, the main mission of the company was to reduce material consumption and waste production. So it was a try and error for the beginning. It was very experimental. And with the years, it started to become a more of a systemic approach. Oh, it doesn't change like that. Okay, that's the first slide. Can you see? Yeah.
Yes.
So our office currently in this building, which used to be a public swimming pool called Tropicana. It's written there on the very, and it's right on the side of the Maas River in Rotterdam, which is the center area where there's the port on the other side. It's kind of a busy area regarding the river. And this building not only was repurposed, but also it is today a circular economy hub in the country, where lots of different startups and also major companies share this workspace. It keeps changing. It's not something that it is right now, but it's continues changing according to the different companies that comes to take to rent for some time. So as I said, although the company started a long time ago focused on this subject, regarding today, Netherlands is considered the top country regarding circular economy. And that's there's a long list here after Italy, actually, but these are the top 4 right now. I mean, right now regarding 2022. And that this still means that we are considered to be recycling, reusing, remanufacturing only 24.5% of the resources consumed. All the rest is still linear. And being a small country, this approach was flagged actually a long time ago. There's a very famous story about how the Netherlands has to curb landfill due to lack of space. So this is a very brief story, a very recent story since 2016, how the government started to already put in place policies that started back in the 1970s into a more circular approach. So before it was more, we went through many years regarding transforming landfills and using waste for energy recovery. There was a lot of investment done in that part. And then we realized that that was not the best approach, even though it minimized landfill. And exporting waste also was curbed a lot due to international policy. We could not more export, for instance, plastic to China or Class C wood to Germany. So things had to be solved locally. So these policies are all part of a long story that has been evolving through decades. So in the last decade, the Dutch government approached circularity as a priority, not only for waste production, but also being more regarding resource security, and in all different fields. So including food as well. Building materials is a large waste producer, and certain materials such as steel and other minerals. So this comes very much close to the mission from Superuse. As the company started, the focus was trying to find local materials as local as possible to complete these buildings. And this approach was not at all a common thing to do. But the distance was already motivated to reduce energy consumption pollution from transportation. So this item, you already understand that the embodied carbon, embodied energy was already a very strong point of the work of Superuse, even though it was not something that was very widely spread among mainstream architecture. So this was a project done by Superuse some time ago. It's a villa commissioned by a couple that they are art dealers, art collectors actually, sorry. A villa like that is a villa in the Netherlands, because normally the houses are all terraced houses. So a house like this is real more is definitely an upper end. And we were very glad with this commission because it really showed that the idea of using secondary materials, there's nothing to do with the value of the design. Normally, I think there has been some sort of stigma for materials that has been used and they're not of a good quality or cannot produce a good design. So I think this project indicates that this is not particularly true. These are some of the materials that were harvested. That's the term we use when we started to identify materials around the location of the project. This old textile factory that was not being used. These are some of the equipment still left there with no use. And there is a lot of material there. And we used for some parts of the structure of the building. And so this is a calculation for the steel structure compared to recycle steel. Reuse and recycle. This is part of the internal area of the house. And here was very much all customized in this project. As you can see, the kitchen cabinetry, some of the drawers are open. They're all manufactured with billboards. It's very resistant material and are taken out of use very quickly. So we use the billboards to make the cabinetry from the house. Also, all the bookshelves are made from the same material. The facade is made from cable reels. So this is more detailed information about the facade. These cable reels are very resistant. They're produced to be for industrial use and outdoors. They stay mainly outdoors. By them, this wood is given for free. You just call them, and if you can go and pick them up, it's absolutely for free. We analyzed the wood. The wood was in good condition. The engineer on board of the team was also agreed to use the wood. The wood was treated, and then we started to draft the design for the facade with it. As you can see, the way we design is mainly based on a previous research of the materials we have in hands, the amount, the shape, the quantity, the quality of these materials. But we also have to take into account research about the costs, how to transport them, to refurbish them, to treat them, and how that component comes to us and can become useful in this new design. So it's a kind of an inverted from the traditional way we are taught at school, that we design first the building according to a specific program, and then we go shopping around for the materials. And actually, the way Superuse works, actually, in my opinion, is a very old way. I think we all humans kind of design like this from its very beginning. We always design with things that we find around. So what I think when this analysis is really critical, if you follow the steps of what that material needs to be reused, it will then be qualified or totally disqualified regarding costs, but also the environmental impact. If the treatment or the transportation weight is too much on this calculation, then it might not be the best option to be used in the project. So this is, for instance, the detail of the facade. And we compared the emissions between using the cable reels, wood, and new wood. And this is a detail of the facade compared with the traditional one. So even though the traditional one, the conventional approach is proposed here as a bench line, we design and build one specific solution, and we calculated However, we keep learning from the projects as well, and we realize that we could even have done further approaches to increase the gains in the emissions. So it's something that we keep learning, understanding further, and then applying in future projects. So in this case here, we could have solved in different ways the detail of this facade to have even a bigger impact. This more recent project, it's actually about to be completed. It's a shared housing project, also in the Netherlands. I think here we can have a better view. This building is existing. The original building is a community center, and very old community center, but the structure, whatever was still in a good shape, we kept in the project. And then we developed the housing on top of the existing structure. Some of these units then are shared and some are private. So they are all apartments. If I'm not mistaken, it's 11 different apartments there, 11 or 16 apartments. And they share common areas. And the process of this project was very interesting because the people who asked us to design the project, to collaborate, they want to be part of the project, even to choose the materials, sometimes to transport the materials themselves. So they were really hands-on on this project. It was kind of very much a community approach there. And for instance, the idea of this project having areas we could cultivate as edible gardens, it was also part of the program. Water saving, energy savings, all these has been part of the program and included. In this project, we used 84% of materials is reused. This picture in the middle here is the King Willem, as the current king for the Netherlands, coming to visit the project. And understanding that it was not only a different way to design and build, but also was a different way in how the clients were involved in the project. This is another project, and this one we did in collaboration with a local architect in The Hague. This is a public building. It's what we call in the US as a waste substation, where you bring the waste yourself that you cannot put on the curb. And we received we won the bid for this project because it was a proposal that had the biggest amount of reused materials. In this case, we reused 60% of the materials are reused or secondary. And the design was done by a different architecture company, and we support them on the material consultancy, material research. So the wood and the metal facade is all reused materials. So here people come and sorry, this is yeah. So this again, what we call the harvest map is we do a harvest map for each project, and you guys are gonna see later on different types of harvest map we do. I mean, it's different because the project is different, but it's the same method for every project. And so we harvest around where we can find the materials that we could apply there. And in this case, insulation, the steel parts, wood were the top ones in the research. These, I don't know, I think you guys saw this before. It's a very, very common component in the steel, let's say, industry. For every product is designed made of steel, these skeletons are produced. So Cambridge University made a vast research on steel emissions in the steel industry, from ore all the way to the diverse industries that the steel goes to, automobile, consumer goods, construction, etc. And at this point of waste production, at this point of the manufacturing chain, is pretty critical regarding emissions. A lot of waste is produced in this manufacturing step, and somehow the industrial mechanism was not being able to absorb these parts very well into the production that they were going on, or maybe the only way they do now is to melt. So these skeletons, for instance, are available broadly everywhere in the US, in the Netherlands, everywhere. And they're left there for scrap processing. So we found this component, since it's available everywhere, we thought it was a very nice element that we could start to investigate further into including the construction industry. So this is our colleague Sen going and selecting the parts that would be more feasible to reuse in that project. As you can see, they are really broadly available everywhere. And so this is a substation, a typical substation. I mean, not typical because not all of them look so good, but as this one. But you come with the waste that you cannot put at the curb, and you put in these specific areas that is denominated the material types. And as you can see, there's almost nobody working there. There's probably one person only at the gate, making sure that nobody's making a mess, etc. And outside is in the middle of the city, this facility. So the design of this type of project is also important, that it can be user-friendly, but also that people start to change their vision about that waste is the worst possible thing, or it has to be far away so we don't see it, we completely forget about it. So I think integrating facilities like this is also part of educating and for us to get used to understanding what are we producing as waste, what we do with it, and it doesn't magically disappear. So this is another view. So as you can see, it's all in the middle of the urban area. Yeah, so this project is a very recent project too. The pictures I have here are really recent at the point that the plants didn't have the time to grow yet. So this project is commissioned by the municipality of Rotterdam. In the Netherlands, we still use a lot of fresh markets, street markets, to buy vegetables, produce, and they are like once a week, twice a week, etc. And people really use these markets compared to go to the supermarket and buy produce there. So once these markets take place, there's been a lot of waste left over, fresh fruits, fresh vegetables, etc. And the municipality wanted to do something about it. So we were commissioned to make a research about what kind of waste is being generated during these events, and what could we do about it. So this is kind of we call a resource station, where it's in the area where the market. So if you can see here on the right side, these are tents for the booths for the market. And very close by, actually, there's a neighbor area here. There's an elementary school as well, and we started to. That's something that the CPUs also does, not besides designing buildings, is try to research ways to connect waste flows or material flows, and how they could be optimized in different ways in that locality, either in this region or city or in the country. So how they can be absorbed again, given a value, rather than having a negative value, which is put in a landfill or burning, which we consider now as a negative value. But so this component as well, this liquid containers is a component that we've been using for a very long time too, because again, they're broadly available, and it's very strong, very sturdy. So this is the research, the data that we produced after we analyzed what comes out of every time the market is set there. and what materials are produced, where are they going to after the market takes place, how much money it takes to get rid of these materials as well. So we started to understand that, okay, can we make something about it? So based on existing local businesses and what is possible to do with these materials, we started to kind of connect these dots, and this station was created in order that this local small business could use the material that was remaining out after the market takes place. So just an example here, we see that this mushroom production, for instance, they consume a lot of, for instance, coffee beans. And there is a kind of, there has been a wave of startups in the Netherlands producing fresh mushroom production for the end consumer. That they are cultivated into bio-based leftover materials. And the same thing goes for brewery waste or vegan. I don't know if you guys know, but this means it's a croquette, is a food in the Netherlands, very, very popular. So we understood that mapping this local business, that it could appropriate this bio waste, it would be an interesting use for this material, and therefore they would be collected in one point. That was then the building we created, which is more a pavilion. So this is a diagram on how this pavilion would work, how the material comes in, and this is, you see the boxes that are left over, everything is collected and sorted. And since there is also here the elementary school, we included a track. So the kids, they use this space. It's kind of, as I said, where the market takes place, but it's also is a public square / space for the school that the kids could use to run in going up and down as an obstacle. So that's how this station was designed, kind of a multi-purpose pavilion. And the roof, there would be a green roof created also with the same containers, and the water would be treated by some of these, part of this green garden, and to be used again to for this to water this green garden. So this is the very beginning, and it was the winter last year, so the plants have been just put in these containers, and that was the beginning of the resource station. So here then we show again for every project which materials came from where. So the idea again of understanding that local materials is important regarding embodied carbon. And we calculate for every project how much of these materials are included in the project, how many of them we can reuse, and how far they traveled to be there. And of course, when we calculate also the impact of the reusing these materials, you really cannot forget that cleaning and remanufacture is also part of the calculation. If you want to make something very complicated out of that component, it might not be the best approach. So this has to be, the remanufacturing part of it has to be taken into account. So this is part of the structure, the containers, all reused. The partitions, office partitions that were also used here. So this is a different project, but I put right after this one to illustrate how we can understand a commission for a building or a pavilion in this case, but we can think in all aspects of impact. So for this very simple project, it was a very small commission. It was a kind of an art piece. It's a municipal building, it's a governmental building, and it's passing through a renovation process where there'll be all these buildings around. They're very massive. They're going to create they wanted to create a kind of a terrace and connect them through this terrace. So the commission superiors to come with something artistic. And of course, we'd never lose an opportunity to come up to push a little bit the boundaries and try to understand what was the role of this terrace to start with, besides just connecting buildings. How you connect this terrace with the garden downstairs, and how we could do this in the most strategic way, let's say. So in this sense, we created then a concept that also superiors have developed for a while ago called cyclifiers. Is that the pieces of design, either building or part of a building, that can cyclify in a way, that, meaning transform all the resources involved in that design into continuous resources. So in this case, the terrace, the part of we were involved in the design of this terrace, was then also a type of terrace that would collect water and filter this water to create a kind of a reservoir, and that not only to again be used in the garden that will be created in that ground floor, but also to bring work as lands for the parking lot underneath. So to create more light, that will be actually today is a dark parking lot. So everything that the project can improve regarding this user interface, it's kind of a sweet spot. You know, the more you can do, I think, to improve the interface with the user in a positive way and the environment around. So that's, I think, an opportunity that, as designers, it's worth exploring. So this is the sketch. It's changing the design. I don't know right now where it is, but it's going on. So, and this is our building, the building we work at together with these other companies. In this case, the building was already existing, and whatever was changed inside, 90% of it was reused materials. And that's a section of it. And again, all the materials we harvested to put inside this building to become an office space. And so one of the components we found, just to exemplify here, was that this monastery was going to be demolished. And there was a lot of window frames that had no end use in this case. So these window frames we used as partitions, but we didn't find this as, of course, that's what means designing with used components, is that they don't come in the standardized or on the size that you want, per se. So we adapted how we use these components in this specific area. We created these angles, so all of them would fit in, create these buildings and these offices inside, circulation outside, meeting space, etc. So this is another example about these lamps are used today. They're in the office, created from packaging, plastic. This is another project, is a restaurant space beside a historical building. In this case, 86% of the materials are reused. And again, each component has its own story. Here, you're going to see the facade, the furniture, the structure, all reused components. So this is the historical building, and it's located in the middle of this public square. And we connected the restaurant to this building. So this is the main structure, the roof structure. It's an existing structure from a farm. The same thing with the bar area. So this is our harvest map for this restaurant. So this comes from a farm, the main structure, this kind of a hangar structure. And how we design, again, you have to adapt because not everything comes on the size or the amount you necessarily will be originally looking for. So this is the way we connect these beams in a crossed way to create these two wings. The doors are reused, the floors are reused, and the part of this steel structure as well from here and around for the window frames, and the windows are used, and the insulation is also used. So this is a detail of the farm building and how we created this structure for the roof. So this is an example how a designer, any designer, could be thinking about how to use the most out of that component, how you can create the shapes out of it that is not necessarily in the way that you found it. So yeah, so I think all these steps are very much relying on design, and the practice of designing. So this is the steel for the foundation here and the window facade. And yeah, so these examples I showed until now, they are examples of building. It's really the practice of an architect. But again, the methodology, as you saw, it's different. And looking for this perspective, we have been doing the same approach in every project. So first we have to understand and investigate the resources, the local availability of this resource, or whatever resource we can find that makes sense. In a sense, as I said, in the sense that I explained before. And up to this point, we decided to create then the same type of knowledge and make available to everybody else that wanted to adopt this system. And we created by then in 2012 the Harvest Map, which was a free to use platform around the Netherlands. And this was before, well, I don't know if it was before, because Craigslist is also pretty old, but it's kind of a Craigslist. So anybody that wants to put materials that are not needed anymore, not wanted anymore, available for the public, then it was there in this website. And since it was built with the designer in mind, we want to make sure that the information that was available in this website, in this platform, was clear enough for the designer. So the size, the amount, the most detailed amount of the specs was there. And it was a friendly user platform. So this started, as I said, in 2012, based on the methodology that we create for every project. So for each project, we develop its own harvest map, what we found, what it is, how much, and yeah, so if it makes sense to be part of this, be used for some application in the building. So the platform changed a lot. This is the old format. And that also was in parallel to libraries. So we created these libraries that we could understand better the material, or there will be study cases about it. So for instance, if you say tire, if you click tire, there'll be all kinds of different information about the tire, what ways you could you should do and you should not to do with that component, maybe for toxic aspects or durability aspects. So every information that was available out there, we packed up into this library. Library. And also the same thing for study cases, not only super use buildings, but buildings and designs from products all over the world that was also there. So this is the most updated version of it. So you can click each of these components, see if it windows, or you can search by material, plastic or concrete or steel, etc. and then the options will come to you and where they are. So again, there was different versions of it, but also, as I said, that it was also different content also. But these platforms are always used with the idea, were done with the goal that the other architects and designers would be involved and would be using this resource, this information to bring reuse as part of their daily practice. In the same sense, this is the Cyclifier. This is a website that talks things that are beyond, then approach that are beyond only building materials, but then it's about water, food, energy, and knowledge, etc. This is another platform we created as a digital one, also called the Wood Guide. So it's kind of best practice that are out there regarding components you can use, how you can extend the life of each one of these wood materials or wood-based materials. Yeah, I think there is very little information that is given at schools on understanding actually the materiality of the components we work with, So I think guides like that are very important. So fast forward, we watched the incredible wave of this type of digital platforms popping all over the world. I think in Europe there's one every month, a new one. This is one in the Netherlands called Sierdax, and it's beautiful. They are extremely complete. They have codes included. They have price compared to new ones, emissions, etc. So it's a very complete platform. And also we see different business models being developed with that. Superuse, by the way, Superuse doesn't run the Harvest Map anymore, the digital platform. This has been sold many years ago to a demolition company in the Netherlands. And so we don't do this part of the work anymore, this service anymore. But we are super happy to see all the startups carry on the work that we started so long ago and adapting with the technologies we have today. So I think again, chapter number 1 was examples of the buildings we do and how we do it. Chapter 2 is about the methodology and how you want to simplify or make it easy and accessible to other designers and other architects. And number 3 here, this chapter is focused on what happened after we created that platform. So we understood, and this actually a long time ago, and that's what some people we see that didn't understand that well yet, and they still creating these digital platforms with the goal, with the aspiration actually that if you just make these materials available, they will be consumed. And we learned that that's not the story. It's not straightforward, that once you know where they are and what they are, how much they cost, etc., it's still not enough that demand will appear for them. So we realized there was one step missing in this chain, in this new approach of design. And then we created a new role within Superuse, and this one we still work with. And it is the material scouter. So these are people within Superuse that helps architecture companies, construction company developers, etc., that they don't want to deal with the material part. So that's example of the waste substation that I showed you guys. That's pretty much what we did there. We helped the architect company to solve that design or to support their design aspirations with our material research. So it's a step-by-step process. It's a straightforward. The architect has kind of a shopping list, or initially tells us what more or less they're looking for, and the amount, etc. And then we start to understand, to look around and harvest. By now, the network of material suppliers in the Netherlands is pretty broad. So, and also we know what works, what doesn't work. and we make then this transaction. Also because some of the players that we saw populating the harvest map, they want the materials to be out of their facility or out of wherever they're operating, but they don't want to be part of the process of people calling or coming and looking for the materials. They don't want to deal with that. They just want the material out in the best possible way that's not the landfill or incineration. So in this sense, this service was required. It was by necessity that it came around. And we have then material scouters all over the Netherlands working with us to collect, to understand, identify, etc. And also it's a step by step. So the demand side will describe what service they want, just to find or even or actually make the commercial transaction, and also including transportation or not. So all these steps are included if required from the material scouter. So these are forms indicating what has been found, how much, etc. This is all documented. It's a documented process. So in this chapter, then I think once you understand how this works, you start to. The beginning is very much, of course, a try and error, but you understand that the linear economy is formed by A to Z and all the pieces in between, right? So there'll be a company that will be occupied with ore, another one that will be melting the sea into plates, another one into cables, etc. So all this network is formed and consolidated. In the circular network, not all pieces are there. So there'll be people that will tell, okay, take the wood, it's for free, whatever, I can even sell, it doesn't matter, it's there. That becomes say, okay, I can transport this wood. There'll be people that say, no, I cannot denail this wood. Or there'll be people that, yeah, I can denail. So there are pieces missing in the process to get to that component back into use. And this is pretty much this word that everybody's using, but it absolutely makes sense, is the ecosystem, the industrial ecosystem is not there yet. So what we try to do is also, when we think about transforming that component again into a new component, we have to not only think about the environmental impact, but also the economic, as I said, but also optimizing in existing infrastructure. So we don't necessarily need to invent a new machine, that does X service to take this coating. I don't know. We try to think about infrastructure that's already there, because the whole idea here is try to get things done by optimizing what we already have, or improving, of course. So the ecosystem is a key component and demands some research. And again, the architect, once he or she is completely divorced from the process of the materials around, it's kind of hard to understand how they function, what's the best way to treat them for the application they're going to be given. So I think it takes back the designer and architect to understand better their métier, what they're really using, and not just relying the total the role of understanding the materials by the manufacturer only. So I think there is some responsibility from our part to understand how they work and how they then can be assembled together within a lifetime perspective, how it can be disassembled, how it can be durable. So all these things are important, I think, in the process. So research is a constant. And of course, the more we test and understand how things work, the more, the bigger we have, it's our portfolio of materials we are working with. This is for instance, as an example of a office tower, and they had to go through a renovation. Many of the things that were inside, they were going to be discarded. And in this case, they're being transformed by these panels here for the air conditioning system, how they could be then turned into furniture. There were a lot of them in the entire building. And so in order to avoid landfilling these materials, we're repurposing furniture in this case. And the same thing goes for every material. So what kind of, so this is, for instance, very low value material. It's not wood, it's wood-based. So what kind of approach you could give or adopt that could elevate the value of that component? So I think this is more or less how we have been, how design can really transform something that is not being used anymore into something with value. Wood, of course, is the lowest hanging fruit for us. It's easy to reshape. You don't need necessarily any high-tech equipment to work with it. So all these are repurposed wood into different applications. The same thing here. And this is a facade made, this is a study, we are studying the facade out of this concrete form wood. And this we did in collaboration with the faunist that helped us understand what was the best way for bats and birds to be part of the design of the building facades. And the client was the ProRail, is the train company in the Netherlands. So, oh yeah, this is the wood guide I mentioned already. And this all,
Lorian,
yes,
Lorian, we have 8 minutes left,
right.
and perhaps after
I'm
the
wrapping
slide,
up.
we can field some questions.
Right. I am wrapping up. So again, technology is coming, I think, to meet us in that point that we're going to be looking to more efficient and more scalability. I'll skip all that. But again, all these are wind blades, etc. How you can this is wind blades actually this project was the very first one, and now we created a spin-off company called Blade Made, only to make objects out of blades, the commissioned blades. They have 25 years only lifespan. This was done last week. So this is a project that from the nacelle is the cabin that holds the engine from the wind turbine, and here we repurpose in a mini house. And this is a project in California, but I'll skip that. And again, I think this is the last slide, is I think part of us in this transitional moment of climate change, whatever, political, social, economic, everything. It's about understanding that our role has also to adapt, and how to adapt in the best possible way that we can understand ourselves as part of this ecosystem. And still having fun designing these things. I think design is still key in this process. So this is just an illustration of a building that we fought for not being demolished. So that's, I think, activism is also part of architect's role. So yes.
Wonderful presentation, Lorianne. Thank you so much. I know that there are some folks that had some questions here before the hour is up. It'd be great if we can quickly answer them. But at the same time, I just wanted to resonate the last slide, right? Is activism. And the easiest part is a choice, right? You don't have to buy special equipment, like you said. It's like the way that we work could be just like working with wood, right? That's the most basic approach. So I appreciate you mystifying that. And it's just that willpower that is basically the basic essence of the work that you all are doing. So I appreciate that. Question from Martin Krop. Is there a concern of UV degradation for the ICV totes?
ICV code.
Totes like bags. Or the planters that you use. I think it's.
Oh, it's plastic. So this plastic is made to be used outdoors. So that's the final application of the original design of this component. So as any other, I mean, you could do the same question, for instance, for PVC window frames, it's not that we don't build with plastic, we build with plastic. And of course, there's its lifespan I don't have by heart right now the lifespan of that plastic, but yes, it's being originally used for outdoors.
Great. Another question from Lisa Pinero Sanchez. The platform looks great. I believe the harvesting map and um, the resources in the Netherlands. Does anyone know if is there a similar upcycling platform in the US or Canada? Can you just give an example? I posted IRS demo on the chat, but
Oh, there are many. I think we saw actually. We saw many coming around, small and big. Also in Canada, there are some popping up as well. But again, since we passed this road, some of these companies, they started really promising that once you put these materials available, people would go there and shop around and problem solved. And we learned it's not that simple. It's one step in the link, so I think I'll be happy to send some names for sure, but there are.
and if anybody needs any resources, they can contact Superuse Studios in Washington, DC, where you are, right? And if
Correct.
they need support or guidance or a consultant
Yes,
or
please do.
collaborator.
Yeah, because listen, we learned we cannot function, and we could not have done what we did alone. Is again, the ecosystem is critical. We cannot do this alone as a culture. We cannot. It demands help from everybody in the process.
Great. Tristan Walker asked or says, this is an inspiring process. Thank you so much for sharing your work. What is the process for developing the harvest map? What is your approach for locating materials that you can reuse? Do you engage with specialty demolition contractors to harvest materials and components from buildings before they are demolished?
Yeah, so there are different steps in the process. And I think right now, even in the US, I think things are pretty mature. So the first ones that I would go knock on the door are definitely the construction companies, demolition companies, and especially the ones that are already claiming to be green. So they will try to deconstruct rather than demolish. So they are hands-on on the materials that you will be looking for. But on the other hand, many of the materials we've been using are also industrial waste. So the cable reuse, the liquid containers, they're not demolition. They're part of from a different market. And there are advantages. And that is the advantage that are coded for construction. But the advantage that some of them come in better shape because they are sometimes even dead stock. So the funny thing about right now is that these platforms are popping all around, and some are even invisible for the architecture practice. There are incredible markets out there, global markets, which we're going to try to avoid because we don't want these things crossing the Atlantic, but that are just selling dead stock materials. So they're brand new, not used, but still they need a sink, and they shouldn't be the landfill. So the process is, again, understanding where they're going to. So for instance, if you want to look for steel, there's a big hit now regarding reuse of steel structures because the steel organization UK has been really pushing to changing codes for people to reuse more steel rather than recycle. So I think this is such a nice moment to new startups come around, just focus on specific types of materials. King County, Seattle also, these guys, they have been even creating hubs to collect and reuse the wood. So it's a very fertile time in the United States to reuse and to push the boundaries because the government is helpful. They are open to change codes.
Yeah, and also push your consultants as well, especially your structural engineer. There's a really interesting case study where a hospital was demolished in Denver, Colorado, and they salvaged all the steel columns. Although the steel columns will have to get cut and testing needs to be done for structural purposes, those tests and that reuse can happen. And Thornton Tomasetti has proven that it can from a structural perspective. So push your consultants as well. Last question, I think we can call it a day so everybody could go back to work or lunch. Matthew Epstein asked, without technical literature or reuse materials, it would be difficult to use them in any fire-rated assembly. How do you deal with fire rated codes or fire ratings for finishes and materials, Lorianne?
Yeah, we treated material, again, when we get the materials in hand, we treat it as a material, not if it's reused or new, etc. Of course, if you buy from the store or from the catalog, it comes out with the certifications. But if you get the wood, there's a group of people working with you. So every time there'll be the engineer. The same question, for instance, people ask many times is how textile machinery became a structure for a building. So this is a conversation with the design team, and the engineer will, as you said, make the tests. And one method that we always use is if you have a component, you're gonna want to use, not, I mean, even the term of reuse is just used in a different ways, but you want to give a capacity that is inferior to what it was doing before. So there's been research, for instance, with wood, how we can prolong the life of wood as long as possible. So there was a study in the Netherlands that we could prolong the life of a beam, a structural beam in a building for 400 years by cascading. So the idea of cascading the engineer capacity of that component is very important. So the idea if this thing is a beam, you turn into a floor, then you turn into a panel for a wall. You have a different type of role, technical role in the building that is inferior for what the need was before. So understanding these applications are very important. You diminish the capacity, but sometimes you increase the value of that component. So cascading is an important word in this process.
Great. And I know we skipped that California project. Can you share just briefly the challenges in working in California and also the benefits that you've obtained or discovered through your process?
So it's still a work in progress. This project is they're all single family homes in South Pasadena, and I don't think we have encountered any wall yet, any barrier. But again, since it's a new terrain for us, we are not going to do the same approach, to start with the same approach as in Netherlands. So we're going to work mainly with the internal parts, first of all. Structure because of earthquake coding, we're going to start to evolve from there later on when we have a mature number of players in the team. So I think yeah, that's our approach. First the internal part of the building, maybe some of the facade, but structural components we're gonna try to do not do for the very first project for now.
Okay, great. Thank you for sharing. And thank you for another amazing presentation, Lorianne. We appreciate your resources, your experience, and your know-how, as well as your time and as well as SuperUse's time and resources. I'll hand it off to Sarah. Thank you, Sarah. And thank you, AI California. Have a great day.
Thank you, Ismar. Thanks.
Thank you, Ismar. Thank you, Lorianne, for a very informative and inspiring presentation. For those who have made it this far, AI California will submit you for AIA credit and can send you a certificate of completion via email. So thank you again so much for today's program and joining us today, and we'll see you at our next AIA California webinar. Thank you.